In today's video we are going to learn about IP address. IP address is basically, you might have seen, 4 octets of decimal number or 4 octets of binary numbers. So before we go into the details of those 4 octets, we need to know decimal number and binary number and how we can change them to each other. Okay. So if let's say we have a number like 1760, so this is basically my 0th position or the ones position, this is my 10th position, this is my 100th position, and this is my 1000th position. So if I have to write it in that form, it's basically 0 into 10 raised to the power 0 plus 6 into 10 raised to the power 1 plus 7 into 10 raised to the power 2 and 1 into 10 raised to the power 3. So that will basically form my 1760. In a similar way, if I have a number this, so this is my, can say, least significant bit, and we start with 2 raised to the power from it. So it's basically 0 into 2 raised to the power 0 plus 1 into 2 raised to the power 1 plus 0 into 2 raised to the power 2, 0 into 2 raised to the power 3. Starting from the next line, it's basically then 1 into, means this 1 into 2 raised to the power 4 plus 1 into 2 raised to the power 5, then plus 0 into your 2 raised to the power 6. Okay, so if we calculate them, then it will turn out to be 1. This is 1, then this is 0, this is 0, this is also 0, it will be 16, and then this is 2 raised to the power 5 is your 32. So it's 32 plus 16 plus 2. So it will turn out to be 50. This is your binary to decimal conversion. So I was on a basically your IP address. So you might have seen a number like 193.16 plus 72.5. Okay, so it's basically 4 octets of decimal numbers, or we can say it's 4 octets, more specifically the octet word is of 8 bits. Okay, what that means is that there will be 8 bits okay, 4 octets of 8 bits. It will be in this form depending upon the value of the number. We will go in detail about it as we go on. So basically the IP address has 32 bits, and I'm saying it's 4 octets of 8 bits. So IP version 4, when we are using, it has 32 bits, and when we are using IP version 6, it will be 128 bits. IP addressing, another thing is that they depends upon the class of IP address is class dependent. So what that means is that if they fall, the number falls under certain range, then it is of a particular class. So ideally we have 5 classes. So classes are A, B, C, D, and E. For us as a network engineer, we are allowed to use only these 3 classes, and these 2 classes are restricted for basically the purpose of D is restricted for multicasting and E is reserved for research and development. Okay, so our focus mainly will be on these 3 A, B, C. So in tabular form, if we have a class A, B, and C, so at this point we need to define that an IP address basically consists of 2 types of information. One is your network, number of networks it has, or the number of networks it belongs to basically, and how many hosts are there. It depends on the class. So we are now going to introduce the length of network. So it's length of network, and then we have number of networks, then your number of hosts. So basically we have these 4 octets. Maybe they are not similarly shown, but they all are of 8 bits. 8. Okay, so we, depending on the class we have, so class A will have 8 bits of network address, then 24 bits of hosts. So it basically has 8 network bits, and the remaining bits are basically your host bits. Okay, number of networks, and it are 126. I'm going to explain why it's 126, because usually when we say it's 126, how 126 is coming, because 2 raised to the power 8 is equals to your 256. Okay, so depending upon the class anything belongs, some of the bits are restricted for a particular class, identifying the class. Okay, we will come back to it. So the number of hosts are basically the remaining bits, which is 32 bits. So it's 2 raised to the power 32, and it's approximately somewhere around 16 million. Then for class B, we have 16-bit for network and 16-bit for host. So 16 bits for network address, let me make it more clear here. 16 for this, so it will turn out to be somewhere 16,384 networks, and here it will turn out to be 65,534 somewhere hosts. You might have another confusion again, that both of them are 2 raised to the power 16, then why net number of networks are 1/4 of it. I'll come to that also. Okay, then after defining your third one is your 34 or 24 bits of networks and 8 bits of your hosts. So it will be 2 million networks if we calculate it, and 254 hosts, which is basically your 2 raised to the power 8 minus 2. Okay, here also there was minus 2 for them, on this side also minus 2. Okay, but we are going to come on that. Before going further, we need to understand why this is 126, why this is 16384. So what happens is that for any class of network, so if it's a class A, class B, or class C, for class A I'm using the term from 1 to 126, which is going to identify my networks. So what we do is that they are in the form of 8 bits. So we restrict the first bit. If it's a class A, then we restrict it that it is always 0. It will always be 0, and the remaining bits can change. So it's basically for all the range, starting from all the zeros to all the ones, this first bit is always constant. This first bit is always 0 for class A. For class B, it is defined from 128 to 191, and we restrict the first 2 bits to 10, and the remaining bits, the remaining 6 bits, they can change. So that's why this hyphen indicate that this is the range. So from this to, okay, so in this way we can say that starting from, we basically have the power to change the numbers from basically third bit. The first 2 bits are restricted because they identify the class. Then for the third one, class C, it is, and the first 3 bits are restricted to this. Okay, the another things which was there, that in number of hosts I mentioned here. So basically that's why it's 126 only instead of 256. Another thing is that which you might come to your mind is that why there's no 127 here, and the reason is that there's a term which is called as local host, which you might have seen. So in class A, that 127 address is used for local host identification, means the loop back. Suppose the host wants to communicate with itself, in that, for that particular address is therefore used for that purpose. That's why we don't have 127 here. these two are not equal to each other, even though they are 16 bits, because in this calculation it is used, instead of using 2 raised to the power 16 to find out the number, we use 2 raised to the power 16 minus 2. So it's basically 2 raised to the power 14 which we are using. Okay, then the last thing with respect to this is 2 raised to the power 8 minus 2. I said that there will be minus 2 here also. Is that for every network which we create, okay, we have a network ID and host ID. Okay, so network ID basically is the ID or the IP address to which your host is connected, or use through which it is requesting its information and receiving the information. Okay, so in every for every host, for every class of host, we always have the calculation when we get the number of hosts, 2 raised to the power minus 8 minus 2, because one of them is used for network ID and another one is used for host ID. So if we have basically 256 address, we are restricting 2 address for a network ID and host ID. We will know about them in detail in the next lectures. Thank you.